when the stars stopped making sense. For centuries, the stars were humanity's most reliable map. They never changed, never lied, never moved out of place. Until one day, they did. To understand why this moment still unsettles astronomers today, we need to return to a time when the universe felt orderly and predictable. The night sky was a reference point, a fixed backdrop against which motion, time, and distance were measured. Civilizations navigated oceans, built calendars, and defined their place in existence by trusting that the stars obeyed consistent rules. That trust continues into the modern world. Space navigation, deep space tracking, and astronomical models all rely on the assumption that stellar behavior follows patterns we understand. Positions may shift slowly over millennia, but never abruptly, never without explanation. The stars, in every practical sense, are supposed to make sense. Then observations began to disagree. At first, the discrepancies were subtle, buried inside massive data sets collected by space telescopes and observatories. A star appeared slightly dimmer than predicted. Another shifted position by a fraction that instruments struggled to explain. Individually, each anomaly was easy to dismiss as calibration error or atmospheric distortion. But the inconsistencies did not fade. As more data accumulated, patterns began to break down across different regions of the sky. Models that had aligned perfectly for decades started producing conflicting results. The math still worked, yet the universe it described no longer matched what telescopes were seeing. For the first time in modern astronomy, scientists faced an unsettling possibility. The problem might not be their instruments. It might be their understanding of the stars themselves. As astronomers examined the growing inconsistencies, concern replaced curiosity, because these were not isolated errors confined to one telescope or one method of observation, but discrepancies appearing across independent systems that had been cross-checked for years. Observatories on Earth and in orbit began reporting results that should have aligned perfectly, yet subtle differences persisted, refusing to collapse into a single explanation. At first, teams blamed calibration drift and software assumptions, combing through code, hardware tolerances, and atmospheric models with painstaking precision. Instruments were recalibrated, reference stars were rechecked, and entire data sets were reprocessed from scratch. Yet each correction only solved part of the problem, leaving behind new irregularities that were harder to dismiss. What unsettled researchers was how familiar the stars still looked. There was no dramatic explosion, no visible distortion, no obvious catastrophe unfolding in the sky. Instead, the universe appeared calm, while quietly violating expectations that had guided astronomy for generations. Brightness fluctuated where it should have remained stable, and positional shifts accumulated faster than long-term models allowed. As explanations grew more complex, attention shifted toward forces that were difficult to observe directly. Gravitational interactions on enormous scales, unseen objects bending space-time, or subtle cosmic effects that only emerged when measurements reached extreme precision. Each theory explained fragments of the data, but none accounted for the full pattern emerging across the sky. The deeper the investigation went, the clearer it became that this was not merely a technical problem. The stars were behaving in ways that exposed the limits of existing assumptions, suggesting that the universe was not breaking its rules, but revealing rules humanity had never fully understood. What once served as an anchor of certainty was becoming a source of profound doubt. And in that doubt lay an uncomfortable realization that the more precisely humanity learned to measure the cosmos, the more fragile its understanding of order truly was. The conflict deepened as astronomers realized that resolving the inconsistencies would require questioning some of the most trusted foundations of modern cosmology, because the stars were no longer just objects of observation, but evidence challenging the frameworks used to interpret the universe itself. models that once aligned stellar motion, brightness, and distance into a coherent picture began to fracture, forcing researchers to choose between patching theories or reconsidering them entirely. As debate intensified, competing explanations emerged, each carrying uncomfortable implications. Some argued the discrepancies pointed toward unseen matter exerting gravitational influence, reshaping stellar motion without leaving a visible trace. Others suggested variations in cosmic expansion on local scales, undermining the assumption that space behaves uniformly in every direction. A smaller group questioned whether the constants assumed to govern stellar behavior were truly constant at all. What made the conflict especially difficult was the lack of a decisive test. The stars could not be manipulated, only observed, and each new measurement arrived filtered through instruments that were themselves part of the problem. Data continued to accumulate, but clarity did not, creating a feedback loop where increased precision only amplified uncertainty. Behind the technical arguments, a deeper tension surfaced. Astronomy had long relied on the idea the universe could be understood through stable reference points, fixed markers against which change could be measured. If those markers were shifting in subtle, unpredictable ways, then humanity's cosmic map was less reliable than previously believed. The emotional weight of this realization was heavy. Researchers who had built careers on refining stellar models now faced the possibility that their life's work rested on incomplete assumptions. Yet stepping away from those assumptions felt just as risky, because abandoning them meant venturing into theoretical territory with no clear boundaries. As the stars continued to defy expectations, the central question grew sharper: whether the universe was revealing a hidden layer of complexity, or whether humanity had simply mistaken familiarity for understanding. The climax did not arrive as a single discovery, but as a gradual convergence of evidence that forced astronomers to accept an unsettling truth: that the stars themselves were not failing, but the simplicity of the models used to describe them was. What once appeared as a stable cosmic backdrop was revealed to be a far more dynamic and interconnected system, shaped by forces that only became visible when measurement reached extreme precision. This realization reframed the anomalies entirely. The stars had not stopped making sense in isolation. They had stopped making sense within the boundaries humanity had drawn around its understanding. Subtle gravitational influences, unseen structures woven through space, and long-term cosmic processes were interacting in ways that defied neat categorization, reminding scientists that order in the universe does not always align with human expectations of clarity. As the dust settled, the field began to change. New models emerged that embraced uncertainty rather than smoothing it away, and future missions were designed with flexibility, anticipating surprises instead of assuming stability. The night sky remained familiar to the eye, but intellectually it had become more complex, layered, and alive than ever before. For humanity, the lesson extended beyond astronomy. The stars had always served as symbols of certainty, direction, and permanence. Yet this moment revealed that even our most trusted reference points can shift when examined closely enough. Understanding is not a destination reached once, but a process that evolves as perspective deepens. Today, when we look up, the stars still shine as they always have, but we now know they are part of a universe that resists simplification, inviting curiosity rather than comfort. And in that invitation lies the true beauty of exploration, the willingness to revise what feels settled in pursuit of what is true. Subscribe to join the journey. When the stars